Hello Math Brainiacs, I am Sir DXTR, your math teacher for today. Today's lesson is all about the concept of probability of events. Are you now ready to explore probability? I hope it's yes. Okay, let's now begin. At one time or another, we'll face uncertainty which is inevitable in life. We may be uncertain on our decisions or may encounter random events along our way. Will your teacher call you for a recitation? Will your parents allow you to join the school's dance party? How probable that these things will occur? The concept of probability is used to quantify these uncertainties. So in this lesson, we will learn together what the concept of probability of events really is. But before that, let us be reminded first of our objectives for today. Let us read. At the end of the lesson, the students should be able to, first, illustrate the probability of events, and second, solve problems involving probabilities of events. As we move on, let us be guided by the following questions. First, how is the number of occurrences of an event be determined? Second, how does knowledge of finding the likelihood of an event help you in your daily life? So, together we will be answering these questions as we discuss the probability of events. What is the probability of events? The branch of mathematics that deals with uncertainty is what we call probability. The probability of an event is a number from 0 to 1 that measures the chance that an event will occur. The probability of an event E, denoted by P of E, can be computed as the number of outcomes in the event divided by the number of outcomes in the sample space. In discussing probability of events, there are several things or rules we need to consider. First, if an event is sure to happen, then the probability is 1. Second, if an event will never happen, then its probability is 0. Third, the probability of an event is a number, either a fraction, a decimal, or a percent. And lastly, the probability of an event E must be between 0 and 1 inclusive, that is, P of E is greater than or equal to 0 and less than or equal to 1. We defined earlier that probability of an event is a number from 0 to 1 that measures the chance that an event will occur. Now, we will take a closer look at the probability line, which will emphasize the rules we have discussed. As you can see, the probability of an event can take the form of fraction, decimal, and percent. If an event will never happen, then its probability is 0. If an event is sure to happen, then the probability is 1. The probability of an event E, denoted by P of E, can be computed as the number of outcomes in the event divided by the number of outcomes in the sample space. It is written as P of E is equal to N of E divided by N of S, where N of E is the number of outcomes in the event, while N of S is the number of outcomes in the sample space. In the concept of probability of events, there are terms that we also need to consider before solving any probability problem. First, experiment. These are activities such as tossing or flipping a coin without looking, which could be repeated over and over again and which have well-defined results. Second, outcomes. These are the results of an experiment or an element of a sample space. Third, sample space. This is the set of all outcomes in an experiment. And lastly, event. These are one or more outcomes in an experiment. An event is a subset of a sample space. I believe we are now ready for our first example. Problem number 1. Jericho has a single 6-sided die which are numbered from 1 to 6. If Jericho rolled the die once, what is the probability of the following? A. Rolling an even number. B. Rolling a number multiples of 3. Let us first consider letter A, which is the probability of rolling an even number. First, we need to identify our experiment, which is rolling a single 6-sided die. Second, our event, rolling an even number. Third, our outcome. In a single 6-sided die, there are 3 even numbers, namely 2, 4, and 6. And for our sample space, there are 6 possible outcomes. We have 1, 2, 3, 4, 5, and 6. So this time, we need to consider our formula. P of E is equal to N of E divided by N of S, or number of favorable outcomes divided by the number of possible outcomes. So here's our solution. P of even numbers is equal to 3 over 6 since we have 3 possible outcomes for a single 6-sided die having even number. So we have here P of even numbers is equal to 1/2, or the simplified form of 3 over 6, or in percentage, this is equal to 50%. Therefore, the probability of rolling an even number is 1/2, or 50%. Let us now proceed to letter B, which is the probability of rolling a number which are multiples of 3. So the same procedure will be observed by simply identifying our experiment, event, outcome, and sample space. So if you have observed, the outcome are 3 and 6. So applying the formula, P of E is equal to N of E divided by N of S, or P of multiples of 3 is equal to 2 over 6, or in simplified form we have 1/3, or 33.33 bar percent. Therefore, the probability of rolling a number multiples of 3 is 1/3, or 33.33 bar percent. Let us now have our second problem. Consider a spinner with 12 equal parts numbered from 1 to 12. Assume that the arrow will only point to one sector nor to any boundary lines. What is then the probability of landing an odd number and the probability of a number divisible by 4? Let us first consider the probability of landing an odd number. Again, the same procedure will be applied by simply identifying first the experiment, which is spinning the spinner, the event, landing an odd number, and for our outcome, we have 1, 3, 5, 7, 9, 11, which are the odd numbers from 1 to 12. And for the sample space, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So applying the formula, we have P of E is equal to N of E divided by N of S, or the number of favorable outcomes divided by the number of possible outcomes. We have here P of odd numbers is equal to 6 over 12, or simplified, we have 1/2, or 50%. Therefore, the probability of landing an odd number is 1/2, or 50%. Let us now proceed to our second question. What is the probability of landing a number divisible by 4? We have here the experiment, spinning the spinner, and for the event, we have the landing a number divisible by 4. And for the outcomes, we have 4, 8, 12, which are divisible by 4. And for the sample space, we have 1 up to 12. So simply apply the formula. We have P of E is equal to N of E divided by N of S. So P of divisible by 4 is equal to 3 over 12. Or in simplified form, we have P of divisible by 4 is equal to 1/4, or 25%. Therefore, the probability of landing a number divisible by 4 is 1/4, or 25%. This time, for you to practice your newly learned skills in solving probability of events, let us now see your probability through a seat work. So it's your turn, Brainiacs. The problem goes this way. A glass jar contains 5 red, 1 green, 4 blue, and 2 black marbles. If a single marble is chosen at random from the jar, what is the probability of the following? P of black, P of blue, and P of not green. You can start answering now your seat work. Have fun, Brainiacs! Let us now check what you have written on your sheets based on the given problem. So we have here the solution to the problem. Our sample space, there are all in all 12 marbles as a total for 4 plus 5 plus 1 plus 2. For the solution for number 1, the P of black is equal to 2 over 12 or 1/6 because there are 2 black marbles in the bag and 12 is our sample space. Next, for the second solution for P of blue, we have here P of blue is equal to 4 over 12 equals to 1/3 because there are 4 blue marbles in the bag and again our sample space is 12. Lastly, for the solution for number 3, we have P of not green. P of not green is equal to 11 over 12 because there is only one green, so we have here 12 minus 1 is equal to 11 that are not green over the sample space, which is 12. So, do you have any clarification or questions so far, Brainiacs? If none, kindly copy your assignment on your notebook for you to practice at home. You must walk your talk, Brainiacs. So the problem goes this way. Earl Darrens is asked to choose a day from a week. What is then the probability of choosing a day which starts with letter S? Second, of the 45 students in a class, 25 are boys. If a student is selected at random for a field trip, what is the probability of selecting a girl? Thank you for listening. Again, this is Dexter R. Afan, MST Mathematics.